All right, let's pray before we start the class. May I request any volunteer to lead us in prayer? Anybody? You don't need to put on your hand because I can't see behind again. Just please, just pray.
Father, in the name of Jesus,
Amen.
I want to thank you, Lord, because you are the everlasting King of Kings. We pray that, Lord, in today's lecture, you will give us the grace to understand it better in the name of Jesus.
Amen.
At the end of everything, shall focus to glorify your holy name.
Amen.
Heavenly Father, we thank you, Lord, because you are our God.
Amen.
Thank you for our facilitator. Thank you for every one of us. Blessed be the name of our Lord God. In Jesus' mighty name, we have prayed.
Amen.
Amen.
Amen. All right, thank you so much. So you have the floor now, Madam Ajay, so that you can ask the question. Just start from the beginning.
Okay, sir. Thank you very much, sir. I want to have the understanding on when we are giving a questionnaire or we are handling a questionnaire, and the questions on
Right,
it
just to wake you up.
is
Just to
either
wake
yes
you up.
or no, or strongly agree, like a liker scale. But while reading the question, each of the item in that questionnaire, the right answer may actually be no. And while we are assigning the score for the former question, the original questionnaire without coding or anything, it is 1, 2, either yes or no. Yes is 1 and no is 2. But in the correct answer, the no is actually a wrong answer, but we have assigned 2 to it. I want to know if that will not affect the outcome of the results by the time we run the analysis. Either it is for the Likert scale or yes or no questionnaire. That's my question, sir.
All right, if I get your question right, the coding, if our coding will not affect the expectation of the result. No, the coding
Yes, sir.
it should not be. The coding is just is a code that is only you that can interpret, and your interpretation is not going to in any way affect what the expected result should be. Okay, if you have used yes or no, which means 1 and 0 or 0 and 1 as you want it to be, there is no statutory way that is mandatory that you have to follow. So it shouldn't affect your answer. At the end of the day, you can interpret your answer the way you want your answer to go. Today, we are also going to mention a few of the things that you just said today on issue of string, because when we started, I mentioned concept of string, that you can't use string to when you use string on your coding, you would end up having some challenges. It's part of the things that we touched briefly, but coding will not in any way affect your result. You interpret your result based on the outcome that your coding is yielding to you. So it shouldn't be at all. Right. Thank you.
Okay. Thank you,
I
sir.
saw another Shodia. I saw your hand up earlier. You have the floor now. Okay. Probably she's not listening or she's occupied with something else. So we have do I have the right? Okay, do I have the right to continue? If you still have questions, please you can just ask the question. I can't see whatever is happening behind. I want to concentrate on the screen here so that the recording will capture what I'm doing. So if you have questions, please go ahead to ask your question. Otherwise, we'll just go ahead. All right, thank you so much. Today I will just start briefly to take us through the t-test. We had a t-test last week, be it the sample t-test or the independent t-test. We want to, what is the real objective? We have done it, but there are some things that you should not forget in a hurry when you use t-test or independent t-test, because both of them are related to today's discussion, which is ANOVA. And by the grace of God, by next week, we'll look at regression. We look at simple regression and multiple regression. And that is where we would draw the curtain, even though there are other analyses that we can learn, we can read and understand because we know the basis. Okay? So, such as part analysis. Part analysis is still there. If you have the time, if you want, I can release the textbook for you so that you can use it to study and also analyze. Right now, we know how to code, we know where to analyze, and we know where to pick the tools. Those are the basic concepts. Also, know how to read and know the theory behind each of these. When I say theory, when you see a question, you should know the statistical analysis that will lead you to it. Yes, don't be scared. You don't know yet, but by next week, between now and next week, you will know. Those are our destination. So don't be scared of that yet. So for the purpose of t-test, it's used to determine if there is a statistically significant difference between the means of two groups or single group, no, and a known value. Means of two group or single group, not more than two groups. If you are talking about more than two groups, we'll get there this morning. But t-test is basically means of what? Two groups. And we'll look at how what forms these two groups last week. I gave us something to do. And I'm sure with those of us who have done it and those of us who are still working on it, you will get something to return at the end of the day. All right, so now we have the independent sample t-test. Sometimes we call the independent unpaired t-test. Means that you can compare means of two independent groups. Independent. Before this module, we have evaluated and see the difference between dependent variable and independent variable. So if you are talking about independent groups now, I'm sure we know what independent is. And in terms of group, means that it is just more than one construct or more than one variable. By the way, when I say construct, I mean variable. So don't be confused. So, and it's saying here different people or objects in each group. Different, not the same. That's what we call unpair. Now, on the other side, we have what we call the pair sample t-test, which is otherwise known as dependent t-test. You know, when the unpaired is what? Different object or different object in a group, in each group. Now, this one is telling us that we compare means of two related. The unpaired was different. The paired t-test is what? Related. Either before or after measurement on the same individual. We'll look at few examples on that. Then for one sample t-test, now one just compares the mean of single group to a known value. You know, it's the same thing as a t-test. Single group to a known value. And we saw an example last week that we went through. Some of us are still on that. All right, when do we use this? When to use? When you want to compare the means of two group or a single group to a known value. I will give us further example as we move ahead in this area. An example is independent p-test. We have the unpaired and we have the paired. As the unpaired is when they are not related. The paired is when the independent values are related. They have relationship, okay? Now let's look at the purpose. Now it is designed to compare means of two independent groups, as we have said. However, don't forget that there are some assumptions that you have to consider before you zero your mind or settle down for what you want to use. One, make sure that the data in each group is normally distributed. When we say something is normally distributed, it means it is evenly distributed from. I showed us an example of that. I think it was last week, what normal distribution should be, and I drew a diagram for us. I'm sure I saved it, and I also sent it across. So when we have a normal distribution, that is one of the assumptions. Each group is normally distributed. Then the variances of the two groups are equal. When we say equality in variance, we talk about it is in statistics. It's called homogeneity of variance. How do you test this? You don't have to use calculator. I will show you how we can, find out these variances in terms of homogeneity of variance very soon. Then your observation in each groups are also make sure they are independent. Remember, independent sample test. Make sure that your observation are independent. So when do you use this in actual sense? When you have two independent groups and you want to see if their means are statistically significant. If their means are significantly different, then you can use that. So that is just a summary of the assignment I gave us last week, because I couldn't run through this before because of our time. And at the same time, I could not spare an hour or two to teach you because we have so much more to cover in the scope of this training. All right, so it's good you go through that on your own. And as much as possible, for those that will be interested to also move further, I can get some other notes for you on part analysis and some data that you can run to get your result. And after we are done with the 7th week, that's also possible for as many as we want to move in that part. So that is leading us to another topic today, which is in line with the t-test, independent, unpaired, and paired t-test, which we call ANOVA. ANOVA is an acronym for analysis of variance. Analysis of variance. AN is analysis, O is of, and VH is the variance there. So it has so much more on the comparison of variance. We talk about homogeneity of variance, which means is it the same and all that. We will see more in this concept. So what is it used for? Those of us who are into experimentation will see more how we can use this a lot. You are doing an experiment, you are talking about an experiment before, and you are talking about an experiment after. You are talking about a variable before and a variable after. And probably there is an intervention, in between. So what is the mean of the value when you start before the experiment? What is the mean of the value after the experiment? So we call this a pre and post test. Either you are talking about introducing a control or not introducing a control. At the end of the day, you want to see the difference when you have introduced your experiment. Does it make sense? Is there a change in value? How do you do that? You can use your t-test. You can also use your ANOVA. You use t-test when you are not comparing more than two groups. But when you are comparing more than two groups, you can't do that. And that is why we say, what is the purpose there? It is used to determine if there is a statistically significant difference between the means of 3 or more groups. When you are talking about two groups, I just mentioned two groups earlier now, the pre and post. Those are two groups. But if you are going further than that, then you cannot use t-test. You have to use what? ANOVA. 3 or more groups. So what are the assumptions? The data in each group is normally the same assumption we have in t-test, normally distributed. The variance of the group is also homogeneity. The variance should be equal. Then observation in each group should be what? Independent. When do we use this? Is that a question? I got a sound behind. If it's a question, just be patient. I will give room for that. When do we use this? When you want to, I just gave us a practical experience of some of the research that we do in Babcock University. Okay, for those of us in sciences or those of us in art, we see how this can play in now. When you want to compare the means of 3 or more groups, for instance, in a class, you want to compare those who are more brilliant between the male counterpart and the female counterpart in your class that you have taught. You can actually use t-test. And if you are comparing more than 2 groups in a class, then you can use ANOVA. Okay? So maybe you want to compare, you are teaching 6 lectures in a semester, and you want to compare and they are all the same level, but different arms of lectures. Maybe you have group A, group B, group C, and they are all in 100 level. So you can use ANOVA to test to see which of these groups actually are getting the best intelligence in terms of assimilation and responses as you expected in class. So you can use ANOVA for that. You will just compare their means and state your hypothesis, and at the end of the day, you will justify the hypothesis as it comes to you. Let's look further on this note. One way ANOVA, which has been defined, compares the means of 2 or more independent groups in order to determine whether there is statistical evidence that the associated population. Please don't forget to always remember some of these terms we use: relationship, association, and all that. You should not forget. Okay, so we're talking about associated population means. If the means are significantly different. If they are, then depending on your hypothesis that you have set, we'll see one of them this morning. So one way ANOVA is what? Is a parametric test. Last class we discussed a number of parametric tests we can do in t-test, and also the one that is not parametric, that we also discover, if you still remember that. But this morning I want to expand more on the knowledge of issue of parametrics and non-parametric tests. When you talk about parametric text, it is assumed that data follows a specific distribution. An example is the normal distribution. It is normal from the left to the right. It scrolls down in a normal distribution in an equal way. While the non-parametric test, is not. It does not have a particular direction. Like we have on the screen here, say non-parametric text make minimal or no assumption about the data distribution. There's no assumption at all. It does not have any form of, it is just anyhow. That's the word. Another word for it is anyhow. Let's see the summary here. Parametric test requires data to fit a specific pattern. It has a pattern. You can predict the pattern of flow, are used when these conditions are met. However, when we talk about non-parametric tests, these are tests that are more versatile and suitable for a wider range of data types and conditions, especially when standard assumptions are what? They are met. It has no particular, it can flow to any direction, okay? Let's see a diagrammatic example of how this works below. Yeah, the first one by my left, it's not label, it's called, when I say by my left, because I don't have a label 1 and 2 here. It's called a parametric test, and you can see the flow. Okay, the flow is from the normal, the middle to what? The end, and it has a particular direction of flow. While the other one, the non-parametric, you can see how it's flowing to the negative to positive is just going flow. And if you look at the one that actually cutting in between the same equal distance from the negative and the positive axis on the x-axis, it looks almost normal, but it's not normal because it's shooting beyond the positive side. So these are examples or diagram of non-parametric test when we talk about parametric and non-parametrics. Okay, just a theory that you should just put in mind. You don't need it, but in case you want to go further on the knowledge of statistics, which is quantitative analysis, you may have to have the knowledge of ability to differentiate between parametric and non-parametrics. Now this test is also the analysis of variance. We have what we call one factor ANOVA, one way analysis of variance, and in one way analysis of variance for non-science area, we talk about between subject ANOVA, between subject and within subject. We'll talk more on that as we move further. So the variance used in this test are known as dependent variable and also independent variable. Remember, we have defined this. Our dependent variable is our outcome. Our independent variable are the variables that will change the outcome. Okay, so please put this in ANOVA. Our independent variable is called factor. When we get there, we'll see how it works. I hope we still have our SPSS working. Let's see, how do we use this? Even though I have given us examples, but let's look at what I have done here. When do we use ANOVA? It's often used, when you want to analyze field studies. I give us example of those of us who are teachers. You are teaching 100 level, and 100 level have about 5 or more groups. Then you can use ANOVA to compare certain subjects, and you want to see the best in terms of the classification between males and female, which of them are actually getting the best. You can use that to determine that. But if you are not evaluating more than 2 groups, then you settle for t-test or independent t-test. Now you can also use ANOVA to also determine the best experiment. When you are doing an experiment, the mean value in an experiment, because when you're talking about the mean value, the lower the mean, the better for you. Okay, the better the result is for you. That's the better the result you are getting. We'll see an example this morning with respect to time in seconds. And lastly, if you want to talk about quasi-experiment, I mentioned example earlier when we have an experiment before, an experiment, a value before and a value after, and you have your experiment in the middle. Permit me to just draw a few diagrams on the screen to illustrate this further in terms of the quasi concept. Now, for the quasi, we are talking about you having two variables, okay? Let me change this color that will connote something else. All right, this is the variable before experiment. Variable before experiment. Okay, let's see if we can label it. Okay, we call it pre-value, pre-experiment, yeah. And this is the post-experiment, which means experiment has taken place already, and they want to see the difference between. Okay, so we can say post-experiment. Okay, post. Okay. Okay. Post-experiment. So that's what we call pre and post. And the one we have in the middle is what we call the intervention. The intervention. Okay, what did you do to change the experiment, to change your pre from the post? So you can call this intervention that took place, or the experiment that experiment that you perform, on the variable. For instance, here you are teaching a class and the students actually failed. You have been teaching them for 2-3 years and they failed your course, and you try to do something to find out, is it the teacher that is the problem or the student? So you have the same student, selected again, and you brought in another teacher. Okay, you brought in another teacher. So you took their measurement, you gave them a test before the class. You gave them a test before the class, just like before our class this morning. I gave you a test, very simple test, okay, on just the normal, probably on what we have done. And I now taught the class again. I gave you a revision on what we have done in the past. Probably a revision from lecture 1 to 5, and I gave you a test after that. So we can now carry out an analysis to determine the difference between what I can now set an hypothesis that the mean value of the pre-experiment will be statistically significant or equal to the mean value of the what? The post-experiment. So may I ask the class, with this kind of group, this is just two groups, between the t-test and the ANOVA, can someone just open up, just unmute yourself and tell us the kind of analysis that we can carry out?
Tester.
Thank you so much. Now let me go further. Let me go further with this. If I now decide to have another variable, I decide to have another variable here. Let's change this color. Okay, oh, this is too dark. Let's change this color. This is control variable, control. Okay, now this is control. The same example, I've been teaching a class and they are not really performing, maybe statistics class, they are not giving me the best as I wanted to. Okay, now I assemble the same class. I taught the class. I brought another teacher who gave them the test. or really, it may not really give them the test. Who took their, just give them a test. Yeah, give them a test without teaching them. Give them a test, and that is the intervention here in blue color, and measure their after teaching, teaching them again, took them, perform a test, give another test. You took the record there and took the record there again. However, there's another group from the same class which you have decided to, take to another environment entirely, because there are conditions attached to what? To experiment, especially quasi-experiment and all that, that you must not allow these people to be in the same environment. This post and what? Control must not be in the same environment, so that information will not flow among them. And if information flows, then you are committing an error. There is a lot of you introduce error in your research. So bias will come in, and that will contaminate your experiment. So you took the control to another university, and totally these people are just on their own. You did not teach them at all. Okay, so you now you gave them a test at the beginning of semester, and you also give them a test at the end of the semester. You allow them to read on their own in order to compare the results before and after the semester. Now, when you have this variable, this is a group, this is another group, this is another group. From this example, which kind of statistical analysis can we use? Please, you can.
ANOVA, sir.
Thank you. And you also check later, apart from the fact that it's ANOVA, check the kind of variable that exists, which we are still going to get through. So I'm going to leave this diagram there. If possible, later I would save it and update with what we have sent across to you. I just try to draw this so that for those of us who are not inclined on numerical or quantitative analysis before now, if this will draw us closer to what it should be. And intentionally, I tried not to use experiment in nursing and other areas, so that I just want to use something plain to us. Now let's look at other conditions that will help us. Now, when we are setting an hypothesis, we can have it this way: statistical difference among the means of two, or when we are using ANOVA, you can use this. You can use it to compare what I have here. You can use it for statistical differences among the means of two or more groups. We have established that. So what do you look into again? Statistical differences among the means of two or more intervention. What I have here is these are interventions, and these are two or more. Okay, that is what we can use ANOVA for. Now, what can we use for again? Statistical differences among the means of two or more change in what? Change score. If there's a change in score, you can use that to also compare the means. And whatever you have established before, that will determine the answer that you come up with. We're going to see a very good example before the end of our lecture today. Note, however, that both the one-way ANOVA and the independent t-test can compare the means of two groups. We have established that. But when you are looking for more than two, you have to shift to ANOVA. Say, however, only the one-way ANOVA can compare the means across three or more groups. Take note. That's why I put them in different colors for you. Also note that if the grouping variable has only one group, then the result of one-way ANOVA and the independent sample t-test will be equivalent. If it's only one group, the result will be equivalent. In fact, if you run both an independent t-test and a one-way ANOVA in this situation, you should be able to confirm your t square equals to what? The f value. Don't bother yourself about this mathematical illustration. We'll go to the result very soon that will show us what we are saying. So let's look at some other requirements that you should look out for before you can settle for ANOVA. Your dependent variable, as we said earlier, your dependent variable should be what? Should be continuous variable. Your independent variable should be what? Continuous. Meaning that your interval, it should be what? Interval or ratio. Continuous because you should have a leading zero. Then your independent variable can also be what? Categorical. Okay, which should be two or more groups. Okay, and we have seen by this class, by virtue of the knowledge that we have, you know, um, we have graduated in this class, all that we have learned at this level. I know very well you can give me example of categorical variable when you talk about nominal and what ordinal. You'll be able to differentiate that, so that shouldn't be a problem. Then number 3, you look at cases that have values on both dependent and independent variable. Also look at dependent sample group, samples or groups, meaning that you can have independent of what? Observation. Remember, there is no relationship between the subject in each sample. There must not be relationship. There must not be relation, meaning that subject in the first group cannot also be the second group. Also, no subject in either group can influence subject in the other. You make sure that they cannot influence. So in most cases, we ensure that they are in different environment so that there's no contamination will not exist. Remember earlier I told you of control and experiment, different environments, so that there won't be a cross-pollination of idea, cross-pollination of teaching and all that. No group can influence the other group. I think we have established this. Then your selection should be done randomly. Randomly meaning that every member of the group should have equal way of what? Method of being selected. Random sample of data from the population. When we talk about randomization of data, we mean that every member, when you have 100 population or 100 sample size and you want to select 10, that 10 you are selecting within 100 should be done in such a way that every member of the population within the 100 unit will have equal chance of being selected. There are so many methods that you can use to get this done. And number 6, normal distribution. I think we have explained this times and times again, meaning that the dependent variable for each group, for each level of the factor, must be on what? Normal distribution. So normal population contribution, especially those that are thick-tailed or heavily skewed. When we say thick-tailed, those that are heavily skewed towards a path, there should be a normal distribution on that. Considerably, that will reduce the power of the what? Of the test. Then also among moderate or largely sample. Remember, the first one is thick-tail, which means towards a particular direction. This population. What do we mean practically with thick-tail? When you want to select among 100, you want to have 10 people, and you discover that within the 10, 7 are male and 3 are female. Of course, that is just skewed data. That data is skewed towards the male section. That's what we mean. You have more of the male than the female. It's obvious. So that's what we call a thick-tailed selection. And the other one said moderate. Moderate means that probably be by 4 to 6. That's moderate, or sometimes 5.5 to 4.5. That's just it. That's what we mean by the normality in the other moderate level. So that's taking us to homogeneity. When we talk about homogeneity of data, homogeneity has to do with equal variance. I mentioned this earlier. Homogeneity of variance, that is, variances are approximately equal across groups. You don't do this with your manual calculation. The SPSS will help us to determine this. Okay, so don't kill yourself with such terminology. It will also be good to know that when you are talking about homogeneity, when this assumption is violated and the sample size differ among groups, the p-value for the overall f-test is not trustworthy. If you don't follow this, the p-value, the solution between the f-test and the c-test, f and p-value will not be what? Will not be trustworthy. Okay. This condition warrants using alternative statistics. Once you see this happening, please just go away from either t-test or ANOVA. Go and use alternative statistics that do not have this as an assumption, that will not take care of this. And such, we have such in the manual that we're going to see today, such as the Brony in a foresight or wealth statistics, which is available via what? Option in one way ANOVA. We'll see that very soon. And other point that we should also consider under the homogeneity of variance is the concept of assumption. When the assumption is violated, that's the previous assumption is violated, regardless of whether the group sample size are fairly equal or the results, he said the results may not be trustworthy, just like we mentioned earlier. For post hoc tests, post hoc tests are tests that we carry out before you settle down for the analysis to determine if you are within the range of ideas or outside the range of ideas of what you should use and what you should not use. And for such variance, we can use a donut C, which we'll see later. And lastly, but not the least, of the conditions that you should consider is that there must not be outliers, no outliers at all. We've looked at some statistical value where mostly outliers are not allowed. We can sometimes, when you allow a missing value, the system will take care of it. So for issues of missing value, it's not too much of an error. But where you will have so much error is when you have an outlier. And we have explained how outliers occur here. Probably one of the things we'll see next week, I will put this down in my note, is to ensure that we see how we can take care of, how we can eliminate outliers when we see them in our coding. Okay, note that when the normality, which means homogeneity of variance or outliers assumption for one way ANOVA are not met, these are conditions that must be met. You may want to run the what? Non-parametric test. Remember, we've explained the difference between the parametric and non-parametric. And last class, we had some non-parametric tests in our, I think it was on our chi-square, okay? It was on our chi-square where we use a particular parametric test, and the other ones were untouched, which were on non-parametric test. So this an example here of non-parametric is the Kruskal-Wallis test, instead of the ANOVA and the other parametric tests that we have. So these are the concepts that we should observe. Let's go to an example that will help us to drive this home today. We've had a number of theory here that would help us. You can skip all these and let's see this area here. I mentioned earlier the concept of treatment. You see, the term treatment, or model and error are the term mostly used in natural sciences and in traditional experimental design. You don't do treatment in business administration. You don't do treatment in marketing. You don't do treatment in social sciences or economics. You do treatment in sciences, natural science, public health, nursing, agricultural science, and other related biochemistry and other related sciences, microbiology and the rest. So in the social sciences, it is more common to see terms such as between groups, and within group used. But in sciences, we talk about treatment. So treatment and within groups, instead of what? Error, the best, the between or within terminology is what SPSS uses in one way ANOVA procedure. So we'll see more of this. When you see it, it determines or depends on where the data is coming from. So sometimes you can see treatment, and some other times you can see between and within groups. Let's look at an example here. There are types of ANOVA actually, and that is what we are trying to say here. If you read further textbooks, you will see what we call analysis of covariance, which we call ANOVA. okay, ANOVA, and we also have MANOVA, analysis of what, multiple variable, and so on and so forth. They have their conditions anyway. The moment you violate a particular condition, such as we have listed, you cannot use ANOVA. You have to look at other alternatives. So you may, after you have gotten this very well, please take time to look at the types of what analysis of variance that we have. We have quite a number of them. MANOVA, ANOVA, and so on and so forth, and they have their conditions. But ANOVA is the popular one that we often use because of the problems that we solve around here. But you can decide to study more on this and learn more. So let's look at the question and see how we can. We don't have problem on where to get one way ANOVA on the tools, but let's look at question we want to solve, and these are our variable that we select. When you open the one-way ANOVA, this is what you will see. You are going to see a list of your variable by the left-hand side, and you see dependent list. Remember earlier we mentioned of the concept of factor. By the way, may I know if I'm still carrying all of you along, or I'm just speaking alone?
Yes, sir.
Thank you so much. Very soon after this discussion, I will just pause for questions and challenges as we may have. So when you open one-way ANOVA, this is what you will see. You will see the list your variables by the left-hand side where you can select from, and you see an open space called the dependent list, and you also see just a line or more called what? Factor. On B, and there's another CDE where you see contrast, post hoc, and also option. So what do we do with all this that we have mentioned? If you are bringing in, because you want to see the dependent list being affected, which is your results being when you manipulate your factors, what happens to your results? That's what you want to see. Not that you don't have results in ANOVA. Your results will be affected or not affected. That's the hypothesis. And probably this morning I will bring a question where we can see that live showing after we are done with the example here. So we have the dependent variable. I've explained that. This is the variable whose means will be compared between the sample groups. You may run multiple means comparison simultaneously by selecting more than one dependent variable, depending on what you want. Okay. Then factors. What do we have in factors? Or factor for single. The dependent variable, which we had, the independent variable, the categories or groups of the independent variable will define which samples will be compared. The independent variable must have at least two categories. We have mentioned this, but usually has 3 or more groups when used in one-way ANOVA. Okay, so those are the concepts we have: independent and factor. What of the letter C? What do we do on letter C here? Okay, that actually is on contrast, and on contrast, which is optional. Most times we don't go there. We just specify the contrast or plan comparison to be what? To be conducted after the ANOVA, after you have what? The overall ANOVA test. It's not. And what do we have here? Issue of mathematical concepts such as polynomial, degree, coefficient, and all that. But usually we don't. Usually our questions are not as complex as taking us to this environment. Okay. Okay, we also have a section called post hoc. We have said earlier that you can run a post hoc test to determine the homogeneity of your data. That's the variance, the level of variance. Is it equal or non-equal? Okay, we mentioned this. So it's a request post hoc, also known as multiple comparison test. Specified post hoc test can be selected by checking the associated what? Checkboxes. We have a number here. We have what the first one, where we have number 1, talks about equal variance assumed. That is when you have equality in your variance. You can pick any of these, and I will tell you the popular one we have been using. You can also study what each of these stands for. And when you have non-equal variance, then you go to where we have what, number 3. Okay, so under equal variance assumed, we have a lot of acronyms here and a lot of meanings. We have the Bonferry, the LSD, the Docan, and the Hochberg. These are various ones we can use when our variances are assumed. Remember, you've not tested it, but it's an assumption. And when that assumption is failed, then you can move to variance. When they are not equal, then you can use any of the ones you have there. You have Donet's T3, Tamfin T2, Game Sowell, and Donet C. And finally, you move to number 4, where we have our significant value, indicated. If you are within the science area, you want to reduce your significant value to 0.01, and that gives room for what? For error space. But for administrative, marketing, product, and all that does not deal with life, you can expand and create more room for error, and that's why we have what? Level of significance to be 0.05. Anything that is less than this 0.05 is significant, and anything that is less than 0.01 for the science section is also significant. And the moment you select your options here, the next one is that you click on what? Click on continue. So if you want to read more on those numbers I've explained, you can please go through this at your leisure time. Okay. And lastly, we have once we have the option. The option we produce another window where you can specify which statistics to include in the output. And mostly we have a number here that you want to see. Do you want to see a descriptive statistics? You want to see a fixed and random effect, or homogeneity of variance test, or you want to see what we call the Brown Fawcett? Majorly, your question will not tell you what to use, but by default, whatever you use here, you must interpret in your result. You must indicate that you use this, and you show us the result, because it's going to affect the result. They don't usually say you can use a description, and you end up telling us that, okay, I have used a description, and this is the value. So you can read more on this also to get more knowledge in this area. Let's look at an example and see how we can solve this. I sent a data on this to you so that you can walk along with me as we go. All right, to introduce one-way ANOVA, let's see an example from a relatively obvious conclusion. The goal here is to show the thought process behind a one-way ANOVA. That's the objective. Now, in the sample data set that was sent, there's a variable called sprint, and I want us to pay attention. Sprint is the respondent time. Now, when you say sprint, that's the running, the level of your speed. Sprinting, you are a sprinter, then it means you can run very well. So what we call sprint here is the respondent time in seconds to sprint in given what? Distance. And smoking is an indicator about whether or not the respondent smokes. Smoking, I'm sure we know what I'm talking about. You can have, and this is a categorical variable, which is a non-smoker to be 0, a past smoker to be 1, and a current smoker to be 2. And if you ask me, how did I allocate numeric values to this? It's just done based on my understanding. It has no connotation to the variable used, and it has no influence on the result, just like someone asked earlier. So let's use ANOVA to test if, look at that, there is statistically significant difference in sprint time with respect to smoking status, meaning that will a smoker be able to run as much as non-smoker or past smoker? That's what we are seeing here. I repeat, let's use ANOVA to test if there is a statistically significant difference in sprint time with respect to smoking status. Sprint time will serve as the dependent variable, and smoking status will act as what? Independent variable. It's just like in a class. You have taught them a course in statistics. You now want to test if actually status, you can marital status, or even sex. If sex has statistically, if sex is statistically significant to what? To the results that they will get in that class. You can. That's another one. That's another way where you can use ANOVA. Okay. You've taught a particular class, not even multiple classes now. A particular class, and you want to test, is it a course in statistics, and a number of them, score very well. But you want to find out what actually influenced the result. Does their sex has influence on the result? And this is also categorical variable. But you discover that here, if you are talking about sex and performance, can someone tell me what kind of analysis that we can use to measure that? I want you please just open your profile and speak to that.
That is t-test for test and performance.
Thank you. I like that. Thank you. It means we are following. T-test, why? Because it's just male and what? Female. 2 variable, not more than 2. But if we have to go to countries like Europe and Western world and probably Asia, where they consider some people to be straight, to be gay, to be hermaphrodite, then you have in a class more than 2. Okay? All right? We have that in a class where we can have more than 2 variables. Then you talk about ANOVA, can work for us in those areas. So thank you so much. I'm happy that we understand this. So let's see how this can work for us. You can just forget about this comparison. That's not good. If you can do it, it's fine, but that's not the objective, right? But let me just take you through. It could be of help to those who want to go further on that. Before the test, what can you do? You can use some descriptive statistics to test if this is actually doable or not. Say before the test, just like we did with the PLT test, I'm sure when I gave you the note, a number of people came back and said, I didn't understand this, I couldn't do it and all that. We're testing for some assumption. And when you test for the assumption, if the assumption is violated, then you have to use other alternative analysis. But if the assumption is correct, then you go ahead. So that's what we call. So sometimes a test of homogeneity can be done and all that, another test. So let's look at what we want to see here. Just like we did with the PLT test and the independent t-test, we'll want to look at descriptive statistics and graph to get picture of the data before we run any inferential statistics. So meaning that I'm going to show you the data, but on this data, you will just run a descriptive statistics. And if you I'm going to run this with us. If you run a descriptive statistics on this data, look at what we have. You're going to have this variable. N is going to be 734 valid cases, meaning that those that are valid data, and just like what we have here. So the total is going to be this. The smoker are going to be this. The past smoker are going to be this. If you look at this, everything here is just lumped up. Let's see how we can run our own and make meanings to it. And also notice that according to compare means, okay, when you do this, you can also compare it to what? The result in compare means. Permit me to switch so that we can see what it looks like to run a descriptive statistics on the data we have just been introduced to. All right, I want to believe you can still see this screen. Okay, this is the data. We have the data here. We have smoking and sprint. And on the smoking concept, I'm looking at it now. There's no missing value. On the sprint, we have a number of missing value. And the total variable here, which is the n, trying to get total n now. including the missing value, is about 300 and wow, I'm still going to 80. Oh, 400. Okay, that's 435 plus the missing value on sprint. Oh, we have some missing value too on the in smoking. Okay, so let's do a descriptive statistics on this. Just go to analysis, go to descriptive statistics, and go to descriptives. We just want to see. Earlier, I have done this, on my private practice, and that's why I moved the variable there. So I'm just moving it back to return it so that we see how it works. It does not have dependent and independent variable on this concept. We just want to see which data is valid, which one is not valid. Remember, we have a total of 435, but a number of missing values are involved. So the system is going to eliminate that. So I run this. If I run this, permit me to switch to the output so that the recording can capture that. And if I run that, okay, we have our output here as this. Look at our output here. We have our output here as this. Okay, this is the output descriptive statistics. I want to request if you can see my screen. Let's see. Let me see if I can make it bigger. Okay. Okay, good. Can you see the screen, class?
Yes, sir.
All right, if you look at the screen, I have descriptive statistics. I have N, I have minimum, I have maximum, mean, and standard deviation, just like we had in the note. But you discover the note was choky. There was no much gap between this smoking value and others. So here we have smoking. For smoking value, we have 411. For sprint, we have we have 374. However, for valid, likewise, valid data, after removing all the ones that are not valid, we have what? We have 353. Okay, and for minimum, on smoking, minimum is 0. For maximum smoking level is what? Is 2, because the variables are just between 1 and what? 0 and 0, 1 and 2. We have smoking, we have sprint, but something is missing. The one that past smokers are not here. Did you see that? Hello?
Yes, sir.
Yeah, that's not
Yes,
there.
sir.
Yes, sir.
Thank you. So that's why we have minimum 0, maximum 2. And we have the mean of that to be what? 0.43. And we have minimum record here gathered in sprint to be 4.5. And here we have what? 9.5. And the mean value is what? Is 6.5. And the standard deviation of both of them is 0.76 and 1.2. So let's switch to the other side so that we can compare what we have here. Please grab this if you can have a screenshot of this so that you'll be able to compare to the other note when I switch. So let's go into the note now so that we compare what we have at the other side. So you discover that, okay, now look at it here. Here we have both of them here. We have the 3 variables here. We have the 3 variables here. I don't know why we are not having the current smokers. Here we have current smokers, and even though it's choky, here we have the total as this. We have the current smokers. Permit me to switch back. I did this earlier. Let me check if what I did earlier is better than what is giving me now on the output level. Okay, let's go. I think this was carried out up earlier. Okay, the same thing. Something is happening which we cannot really see now. It's hidden. One of them, okay, it's hidden. One of them is hidden. The same thing happened earlier too. Okay, when I did the 3 of them, only 2 were showing. Smoking and sprint. Okay, which means, okay, here it combines the 2. The same thing happened earlier. All right, let's switch back. We'll get to this later. That's not really our destination now. Let's go back to so we have this here. assuming that you want to carry out this, just like we said, the valid data here is what 374, and our own valid data in the output. Who can remember our own valid data? Was it 374 too? Are we together?
For sprint, it was 374. For smoking, it was 411. Valid is 53.
All right. Thank you, which means it's correct with the total, with the 353 here. Okay, thank you. Right, that's if you want to compare the means, that's what you get. Now, notice that according to the compare means, if you compare means that we did earlier, about 3 weeks ago, procedure, the valid sample size is going to be 353. This is because compare means, and additionally, the one-way ANOVA procedure itself requires that there is no what? There is to be what? No missing value for both the spring and what? The smoking indicator. It's going to remove the missing value to ensure that there is non-missing value that is actually in between. Now, how do you get this one? I want us to go and try our hands on this. We want to get this compare means. Okay, let me just show us. We want to get compare means here. I'll just show us what we do, because here you go to what? You go to box plot. Remember last class, I think I showed us how to create a box plot. You want to show a box plot where you want to see if this outlier, there's an outlier, and how your result will look like. I say from the box plot, we can see that there is no outlier. So if there's outlier, we have some point, we have some result that will be scattering around. So let's go back to how we can see how we can get this done. Let's switch from our recording, how we can get a box plot on our SPSS data. So we are back here. How can we create a box plot here on our result? Remember the last time you go to graph, go to what? Legacy option, or sometimes you can go to box builder, but that's going to take you a longer time. You will also see box plot here, which is here, okay, which is here. All you need to do, select the one you want and go to what? And go and what? Go and define your element, which is still the same thing. But let's just pick from outside and go ahead. Graph, legacy, box plot. You can't just take simple. Summarize for what? Group of what? Cases. So you can define your data. Okay, I was trying to look at this earlier, and I did some practices on the box plots here, and that's why you saw the variable selected. So here, depending on what you want, rows and column, select your box plot as you have, and you look at it, nothing is happening here. Nothing is happening here. So let's return, which means our selection is wrong. And the moment you see that is wrong, your reset or your paste or your continue will not be active. So how can we get that activated? Category on x-axis. Okay. Both of them are still not active. I don't know what is wrong here. I've done this today with a result. Okay, good. So we have the variable, which should be on the variable, and the category on the axis. Okay, and the moment you have this done correctly, you will have your continue button will be active. The continuation button here is okay. If you click on OK, it's going to show us, it's giving a lot of warning anyway. It will be included in the box plot. A lot of warnings are here, but the major thing is there are number of what? There is no outliers here, but the variables are jam-packed. It's not as clear as what we have outside. If we have more time later, I will take us through how to generate a better box plot before the end of the lecture to determine the homogeneity of our data. This is just to test. Sometimes we don't report this, like someone asked in the last class. We don't report this. We don't report this section. We use it to test what we are actually looking at.
Sorry, sir. How does it show that there's no outlier?
Yeah, we can't see it very well. You can see that these are charts, okay, and it's not very clear. It's not very clear. These are charts. It's not very clear. Like, well, let's see if we can. Let's go back. Oh, sorry. I need to switch. I need to switch to the output. Otherwise, the output is not going to. The video recording will not capture this. The question here is that how do we know that this one has no outlier? The correct answer is that there is no way, because the diagram is not clear. It's clumsy. We need something that will be bigger than. It's too tiny. We need something that will be bigger than this. So let's redefine this. Let's go back and see if we can redefine this to give us um, a better diagram, such as we have in the example. Okay, let's go to the graph now. Let's go to graph builder and see if it will be better for us at this level. Box plot. Okay. Let's choose this. Okay, now we have basic. We have element property. Let's look at basic element. And choose axis. What do we want to be in axis? Okay, we have chosen this. What of choose element? We want this, something like this. And group, any group, nothing. There's no cluster. Do we want a title? We can't even select. Something is wrong. Check items and title and footnotes. We can't even choose a title. Let's look at element properties. All these are not also, they are not active. They are not active, so we cannot even apply. So something is, there's an error somewhere. There's an error somewhere. We have our input here. We have our input on both variable. Okay, something is wrong. Something is wrong, that we is not appearing where it should be. All right, I will find out this later. Just give me some time. I will find out this later and get back to us and find out why we is choky tiny that is not giving us what we should have. But for now, let's continue and see how we can go further on the note we have. I will find out more on that later. But for the note, we can see this here. For the diagram we have here, I hope this is visible to everybody. Can we see the screen?
Yes, sir.
Yes, sir.
Thank you. All right, let's look at this here. For what we have here, you discover that your answer is just, your output is just within this range. If we are to have outliers, class, we're going to have multiple. We're going to have a lot of dots around of figures like this. That's outside the defined environment here. We're going to have a lot. I would find time to show us how we can generate that by first time by next class, or I send another video recording between tomorrow and next, so that we'll see that. I don't want such to shorten the required time that we're supposed to use in our class for next week. So let's just assume we would have scattered outputs. Apart from having all these three, we're going to have another scattered outputs here. It means that we have this, our word has outliers that we cannot use, or we take care of it rather. All right, so let's go on to analyze our data on ANOVA now. Now, for those of you who want notes, the note is here, and at the end of the day, we're going to have this result. We're going to have this result. So let's just go there and see how we can compare our results to this. Okay, so we'll go to the recording and see how we can change to analysis on the data sets. So we'll go to analyze. You don't need to do any selection. Go to analyze and go to compare means. And on your compare means, select one way ANOVA. And I'm going to return this. I'm going to return all this so that we start from the beginning together. Okay. Remember, the note says that your dependent and what factor dependent list has to do with the expected result that is being manipulated by what the factor. So the dependent list is going to change after the experiment has taken place or remain the same as it were. You cannot, you are just projecting, because if you say it's going to change, then why are you carrying out the experiment since you know it's going to change? But this is a result that you don't know. You have a hypothesis that an assumption is was just created, which you may be right or wrong. So what we are moving to the dependent list is the sprint. We are saying that smoking will have effect on sprint. So we don't know. So why smoking is what is the factor. And remember, smoking here has three variables, you know. So we have the smokers, the non-smokers, and the past smokers. So we move them here. And do we have any? Let's see our notes. Are we supposed to pick any other thing? So that otherwise, if we run this without comparing to the note, we're not going to get the same result. Okay, so let's be sure that we are working with the same concept. So I move us back to the note, and let's see the variables of selection here. Okay, we pick dependent list has been picked. Then okay, we go to option. After picking the smoking to what? To factors, click on option and select what? Mean plot. Then we continue, and I think that is all. So we switch back to okay. So once we are here, we go to options and pick mean plot. Well, this was not by default. I've worked on it before now. That's why it's picking what? Mean plot. Sometimes it may pick, depending on what you have used back, it may pick that. But because I've worked on this morning, that's why I have what? Mean plot being what? Appointed. Meaning that it's going to give us our result in a mean value. So your analysis is going to come with in what? In form of mean. And at the end of the day, you should be able to interpret that. I'm going to ask few questions very soon anyway. So you click on OK. The moment you click on OK, let's switch. Otherwise, this recording is not going to capture our output. So go to output and we go exactly to our output screen. Now we have our result here. We have our result here. Okay, we have our results just like we have outside. Now, we have our result as sprint. Remember, we are talking about sprint now and smoking. You discover that this actually is talking about between groups and within groups. If we move this now to public health and nursing, we're not going to talk about within and between groups again. We're going to talk about intervention. So that might change as regarding the theory we went through earlier. So on the sprint, we have the sprint and we have the sum of square. You know, we have the sprint, and over here, this is the result on the table. We have the sprint, we have sum of square. Between groups, we have this. We have within groups, we have this. We have on the DF here, we have the 2, we have 350, we have 352. We have mean square of 13.3. We have that of 1.47. We have the frequency as 9.209, and significance is what? 0.00. Now let's look at the diagram here too, because we might not come here again. We just go and read. The same thing is what we are getting with, and as well as what the author got in the note. Let's compare what we have here. Now, may I ask a question here? Look at the smoking level here. The person here is, I wish I can draw here. This is no word here. Okay, let me see. Okay. I wish I can draw here. Okay, you can actually indicate your title here and all that, but we are not into that now. That's not our objective. All right, I want us to understand something here very, very well. Here, when we're talking about mean, we want to look at compare our result to mean, because this is the smoking individual. And we have those who are zero and non-smoker. These are people who are smoking right away. Okay, which one is past smoker? Is it 1 or 2? May I ask the class?
Past smoker is 1, sir.
Thank you. Which means these are the current. Current is 2. Current is 2. Thank you. Now with this,
It's 2.
thank you. And we have the mean of sprint. We have 6. This is the mathematical difference between the scale that is used there. We have 6.4 here, 6.6, 6.8, which means we have 2 in between, and 2 in between, 2 meters in between. Okay, and eventually we have 7.2. May I ask us here, just a simple mathematics. When we are talking about mean of value, is it the bigger the mean that has significant value, or the smaller the mean? What do I mean? Well, let me finish before.
The smaller the mean.
Let me. Yeah, I want everybody to understand this. Okay, when I say I have a mean of 7.2 here, and I have a mean of 6.4, can someone tell us the difference between that? Are we saying that those who are in 7.2 have higher, are running better than those who are in 6.4? I want us to understand this. That's why I'm bringing this, so that will help me to really bring this closer to everybody, because something is going to happen now, and you like, wow, why is it like that? Is it supposed to be like that? I hope the question is clear. This is people who are smoking.
Yes, sir.
All right, please, can someone explain to us?
Yes, I would say it has been established that the lower the mean, the better the result. So in this situation, the mean of 6.2 will be considered to be better, because that is the average mean, result that is more appropriate.
Thank you.
That is the end.
Thank you. Now, thank you. I just thank you for that, because something is going to happen now. We discovered that if you draw a diagram here now, these are, look at these people. This person on 2. Exactly. This person on 2 means that he's an active smoker, isn't it? He cannot do anything. He cannot run anywhere. Look at what he's covering. Look at where he's covering. Where somebody who is not smoking at all, is having the speed is better, far better than this. And the person who is what? Who is still what? This is somebody who has smoked in the past. This is somebody who is still smoking here. Who has smoked. Okay, this is somebody who have less smoking. Okay, look at his own here. Is here. So averagely here we have what? We have the non-smoker person making a what? A better sprint, running faster than what? Those who either have smoked in the past or are still smoking. So let's go to the report now, because once we understand this, the report will be clear to us. And by the way, this report is not constant for every question. And in the next few minutes, I'm going to draw out a question that we'll see how we can analyze, how we can see. I will draw a question from a proposer, not from a postfield, so that we will see if we can decode or we can interpret the statistical analysis that is required to run such. So let's switch back to the report on the note. Now, having run that we saw and compare that with what we have, it's the same thing, gentlemen and ladies, between group, within group. And we come here and we have the same value. And we now come here, okay, good. Even it's labeled, this one is labeled. We can also label our chart, by the way. We can label our chart. If you want us to do that, we can go back later. We can have the non-smoker to be 0, the past smoker, to be 1, and the current smoker to be 2. Past smoker, yeah, current smoker cannot run at all. Past smoker, yeah, I think the heart is getting better, or is being healed and all that. They can still make some little speed. But the moment you are overwhelmed with a lot of this, the medical people will tell us, do you smoke cigarettes? The more you smoke, the less you exercise you can do. You just run a little, you cover a little speed, and you'll be what? You'll be gasping for breath profusely, as if someone who has been running for hours. So let's see our result here. Mean plot is a visual representation of what we saw in the compare means output. The points on the chart are the average of each group that we have seen. It is much easier to see from this graph that the current smokers had the slowest mean sprint time. We have established that. Because if we didn't establish that, you'd be wondering, how can someone who is current smoker, he can run 5 fast now. That's why it's going what? It's going up. But you discover that the more the value of the mean, then the lower the what? The result. So take note of that. If you are using mean to report your descriptive statistics, those of us who are here to, do a project, you should know what to do. The higher the value, the poorer the result. Now, the point on the chart are the average of each group. It is much easier to see from this graph that the current smoker had the lowest mean sprint, while the non-smoker had the fastest sprint time. Now let's see how do we write this result. We conclude that the mean sprint time is significantly different for at least one of the smoking group, and we have seen that. How do we get our F2? Where do we get our F2? Our F2 is here. This is our F2. Difference of what? Of freedom. This is our F2 here. Then what is our F? How do we get our F? Our F will be what? 355 minus 2. That gives us 350. Let's see if that is correct. So, okay, our F2 is what? Our F2, you now write it this way, that our F is 2, 350. How did we arrive at 350? The total, the DF is degree of freedom. So for you to get the degree of freedom, it is the total number minus what? The F value, which is minus 2. Remember, this is what we have here, right? This is the total N here, and what? Degree of freedom. So 2 minus this gives us what? Gives us the 350 there. So we have F2, 2. So if you make any error, or you didn't know what to write, or you write jargons, they will pick you up there by the time you show the table and you show this result and it's not equivalent. Then your F here, what is the value of the F on the frequency up, which is 9.209. Let's go up and see. Yeah. On the frequency here, look at it here, where you pick your 2 here. The frequency here is what? Is 9.209. At what significant level? So the entire result you are showing is between this 2 and this and what? And the right hand side, which is this. Oh, okay, which is that. And we come down and see that it is written this way. And please take note that your result, your statistics here should be italicized. You can see that it's in italicized form. Your F is in italicized form, the result is normal, and your P is what? Italicized, and the result is normal. Do the same always for upper 7 representation. Say note, and our P is what? Less than 0.01. This set, yeah, it's less than 0.01, which means that, and we set our P for it to be significant, it should be what? Less than 0.05. But here we're even getting it, it's even less than 0.01, which means this is highly significant. Note that the ANOVA alone does not tell us specifically which means we're different from one another. It says here to determine that we would need to follow up with what? Multiple comparison, or what we call a post hoc test. We can check that up in a class later, or I can send a note to us so that we can read on that. All right, may I ask question here? And after this question, just pause a little bit, just mute your profile. You can ask question, you can contribute. And after now, when we are done with question and interaction, I will just go and pull a question somewhere, from the pre-filled, and we would analyze and see which statistical analysis that is suitable for such, so that it will really broaden our understanding of what we have learned. All right, question time.
Yes, sir. I have a question of this degree of freedom 2.35. I don't see how they get it. You
Oh, okay, let me increase my screen. I don't have, where do you have 2.35?
2.350.
Oh, sorry, let me increase,
Decision and conclusion.
let me increase my screen. It's not 2.35. Is it clear now, Mr. Deogratis? Is this clear now? It is. It is degree of.
2000?
It is degree of freedom. It is 2,350 equals to 9.209, and I will just I will take us to where we got this now. Let's just let's go up again. Just keep that in your memory and let's go up. Look at it here. If you look at this, I wish I can expand this, but it's jam-packed. It's clumsy. Okay. All right. Let me see. Let me change us to our own record. Let's go back. This everything is lumped up here. It's not properly. There's no space between sum of square and degree of freedom. Let's change the output section to output there. I'm trying to copy our own result. I like to use our result. Our result is clearer than what we have on the screen. Let's copy our result and bring it back there. Okay. Good. Now, this is it. This is very clear. Even though we cannot report what I brought in now as our result, it should be reported in a single table format like we have. We should remove some things that are not necessary. That's why we have it this way. So the best result for our project should be this, not this one. You will just create your own table and remove things that you don't need. But this one is still clumsy. There are some things that we don't understand here because they are close to each other. Now look at this. For those of us who are asking for where we are getting our F, this is our F, degree of freedom. Our F is what? 2. Now where did we get our, and this is our
the
N.
difference of the two.
Exactly. This is our N. Our
Taking
N.
the total minus within.
Thank you. So this is our N. What is our N? Which is our degree of freedom? Which is what? Which is 352 minus what? Minus 2. 352 minus 2. Minus 2. And that gives us what? That gives us 350. And we are now saying 350 equals to what? 9.209 at what? P less than 0.01. I don't know. Is that clear now? Is that clear now?
That one is clear. The problem is that the value of 2.350.
Oh, we don't have that here. We don't have that here. Look at what we have here. Where did you see?
F2.350.
Yes. No.
Okay.
This is not 2.
Okay.
This is comma.
It's a pair of something.
Yes.
Okay, thank you so much, sir.
You're welcome.
I was thinking it's a comma.
No, it's not. It's not full stop. It's a comma.
It's a pair of two values.
Yes.
I understand now.
Yeah, that's how you report in ANOVA in a t-test. That is how we report our answer.
Very clear now.
Thank you. Can we listen to other questions or contributions? Does that mean that we understand this, everybody? Okay, let's put something together. Let's put something together. This may not show, and I don't want this to actually show in the recording, because I'm going to put something from people's record. I will just once it's out, I will let us see. I want to put. I'm sure we can see the screen very well, but it's not going to show in the recording, which is perfectly okay for me, because this can, has to do with privacy issue. Okay, this is my section where we evaluate projects. So I'm going to pick something from PhD class previewed. let me go to nursing. Okay. PhD, public health, PhD, public health, nursing. I'm going to pick a previewed level. Let's go to previewed. I'll just pull out any record. Just a minute, it's going to change. Okay, let me pull this out. We don't have issues with the name. I'm going to eliminate the owner, the name out. So I've just downloaded that document and I open. I'm going to eliminate the name so that we don't have anything to do with the name. What we need there is the title. Okay. Good. So this is the title of this research. Can we still see the screen, everybody?
Yes, sir.
Okay, and I remove the supervisor. I'm just going to go straight ahead. Permit me to include this now to the recording. Let me include this now to the recording. It's going to take a while, a little bit. Example. Call this example. Okay. Then we create an example here. Okay. Good. All right. So it's the recording. We capture this now with what I've done. Okay. Please, I want us to capture this very well. Developing a framework for collaboration on implementation of whole school and whole community model in public school in Osun State, Nigeria. I repeat, developing a framework for collaboration on implementation of whole school and whole community model, meaning that a model is used for whole school and whole community in public school. Well, what this is doing, I don't know, really. I can't see any problem there. But anyway, let's look at just the objective. And from the objective or research question, let's see if we can determine what statistical analysis, both from descriptive and inferential statistics, that we can use. That's our objective. Forget about the problem, the title, and all that. What we are interested in getting out is that if by now we can predict our solution, what we need to use, then if we can do that, then we are good. And if we are still struggling with that, then we can also get to destination. So let's go on and see how we can get this out. And there's no hypothesis here at all. Okay, we have about 2 hypotheses. I'm going to copy that. Let's see. I want to eliminate some things so that this can be clear to us. Let's push this down. Number 1. Let's look at this number 1. Number 1, he said to conduct a need assessment. Forget about this. This is not something we can determine. That is a need assessment. Now, can someone tell us here? Let me see if I can expand the screen better than. Oh, good. Evaluate the knowledge of the stakeholders on importance of implementing what? Whole school, community, something. It has to do with whole school with the title. This is not a good one, but I wish I can get a better title with us. But let's just see how we can do with this. Let's see how we can manage this. Please, the acronym here has to do with framework for collaboration of implementation of whole school and old school community. So it's old school and old school community. Old school and old school community. Old school and what? Whole school community. So here we are talking about number 2, evaluate the knowledge of the stakeholder on importance of implementing this. How do you think we are going to represent this in our output? Which statistical analysis are we going to use here? I want someone to tell us. Just let me help you by solving halfway all that we have in our objective. In our objective, or our research question should be descriptive statistics. So don't go too far. They are all description here. So from the description, can someone tell us how can we evaluate the knowledge? What can we use to do this? We have actually done it in class to get this answer out. Evaluate the knowledge of the stakeholders on importance of whole school and whole school community model. Anybody?
Maybe there is a kind of score from stakeholders. Score recorded.
Yeah, I know. I'm just asking, what analysis?
We have to use descriptive statistics.
Yes, I have answered that for you, madam. You are still giving me the same answer I gave to you. We're going to use descriptive statistics, there's no doubt about that. But on the descriptive model, which one? Yeah, I think, you are right. But can you just tell us an example of a description that you recommend us to use? We have a lot. Can you just give us an example? It's descriptive statistics, but can you give us? We have a lot there.
Yes, sir. The mean, we do the frequency, then the mean, because it's answering, knowledge is answering yes or no.
Yeah, thank you so much. Do we all agree to this? It's just the frequency that we need to display. The frequency distribution. Do we all agree to this, class? Hello? Is she the only one? Hello?
Yes, sir. We can hear you.
Do we all agree to our solution?
Yes, sir.
Yes, sir.
Frequency
Yeah, Mr. Deogratis is saying he doesn't understand. Usually, by the rule of thumb, our knowledge will be evaluated based on what? Yes or no. Is that not true, class? It's either you know or you don't know. Is that not correct?
Yes, sir.
That's it. That's correct. So at the end of the day, we want to evaluate the knowledge of the stakeholder on the importance of this. So if you go to the questionnaire, which I don't want to take us there, I don't want to take us to getting the questionnaire right now. But if you have to extract the questionnaire, you discover that the owner here has actually mapped knowledge to what? Yes or no. At the end of the day, you code it in your statistics as what? 1 and what? 0. And also the knowledge of the model may have been assigned to what? Another thing. Another thing. So this is just to tell us that how many people are in this area who are choosing I know or what? I don't know the model. It's just a frequency distribution display. And we also explain, just like our first practical we had. Are we together, class?
Yes, sir.
Okay.
Yes, sir.
We cannot solve this until we get the data. That is obvious. But someone asked a question sometimes 2-3 weeks ago that if we see questions, how do we determine the solution? And that's why we are here. Now, let's look at question 2. Assess the barriers to implementation and components of what? WCC model. May I ask you, what statistical, descriptive statistics do you think we can also use to show this? Anybody?
Descriptive.
Yeah, it's descriptive. We want the kind of description. Everything is descriptive here.
Frequency.
Hello?
Frequency.
Yeah, we can use frequency. We can use a bar chart. We can use histogram to show the barriers in terms of diagram, in a diagram level, in a diagrammatic way. We can use frequency. We can use bar chart. We can use pie chart to show this. Okay, and if you look at question number 3 is wrong. Develop a framework. We cannot assess that with what? With SPSS. And most of the things, this is what we call proposal. Most of the things there are 0. When I say 0 level, very, very wrong. Let's look at number 5, which is number 5 here. This is the number 5. It says assess the relationship. This is a very, 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 very good question. Assess the relationship between knowledge of stakeholders on effectiveness of WS school something community and what? The implementation of the model. Assess the relationship. May I ask you, class, how can we assess relationship in descriptive statistics? We use what?
Correlation.
Yeah, you didn't get my question. Can you assess? Can you use? That's inferential statistics. It is wrong. This question, it should never be here. And each time I tell my students that your questions, this is a descriptive section, and you are bringing inferential question to a descriptive level. These questions can never be solved under this objective. It is not supposed to be here. It's supposed to be under your what? Under your inferential statistics. And unfortunately,
most of... to use hypothesis?
Yes, you are supposed to use hypothesis. And unfortunately, those who are leading us do not understand where descriptive statistics, the limit of descriptive statistics, and where questions should be and where questions should not be. These questions can never be assessed by what? Descriptive statistics. Does descriptive statistics show you relationship? Class, since the beginning of our study, have we done any question on description that shows us relationship?
No.
No, sir.
So one of the objectives of this class is for us to determine questions that are wrongly worded with the expected solution. So this question should never appear here. Instead, it should move to what? Hypotheses, where we can show relationship. Yes, you gave me the tool we have to use, but where that question is wrong. Because you are not supposed to use inferential statistics under what? Descriptive questions. If you want to use inferential statistics, then the question should be moved to where? Hypotheses, and then worded rightly. It's not even worded rightly. I hope this is understood, class. Hello?
Yes, sir.
Yes, I hope we understand this.
Yes, sir.
If we bring the question here, fine, that's possible. But under description, we cannot do inferential statistics. Inferential statistics is only done under what? Hypotheses. All questions in objective and research questions should be handled with what? Descriptive statistics, which is very simple. I expect every one of us in the class to be able to handle that. Basic is just the basics of where we started from. The mean, median, mode, frequency distribution, chart, pie chart. We can use all that to explain that. Line graph, we can use all that to explain everything in descriptive statistics. Now let's start with inferential solution here. The author is saying here that there will be no significant relationship. Watch out. We have seen significant relationship this morning. However, between what? Barriers. We cannot determine this barrier until we see the question. I hope we know. And implementation of this. So we have to go and look at barriers and look at what? Implementation, and see the kind of variable we have there. Do you agree with me in class?
Sir.
Do you agree with me, everybody?
Yes, sir.
1, we need to determine if this variable are single variable or multiple variable. We need to determine if the variable actually continuous or what? Categorical. Do you agree to that?
Yes, sir.
So I want us to go right now. I'm going to flow to the questionnaire. We're just going to compare the questionnaire on barrier and implementation. Then we see the kind of questions asked there, if it's continuous or what, or categorical. Then we now determine the type of relationship. If it's going to be a T-square or what, or an ANOVA or a compare means. Let's go. I'm just going to go down. With the assumption that the question is properly developed.
Hello, sir.
Yes, sir.
Yeah, what the objective of this project, sir?
Yes.
With the questionnaire, are we going to wait for the questionnaire to come before we can marry all these things together?
Yeah,
because we have not seen the questionnaire now, and the statements of problem is telling us assessing, evaluation, relationship. But if the questionnaire does not marry them together, how do we determine that, sir?
Good question. I will definitely I will answer that. Okay, good. We'll answer that after now. Let's pick this first. Okay, this is the instrument here, and we go to where we have what. For this session, you are required to choose an option most suitable to your. What's the title here? Consideration of. Jesus is Lord. There's no title here. And meanwhile, we are looking for what?
Barrier. This is practice.
Okay, let's see if we can get barrier. Thank you. This is practice. We also need practice. Anything on barrier? These are descriptive. These are social demographic variables, and they are so long. Do you have school health? Wow. I think barrier has been mixed with what? Social demographic variables. How to promote implement. This is implementation now. This is the implementation. An implementation that the author used here. Let's look at this, class. The implementation the author used here, he used a Likert scale, most suitable to you. Very effective. This is, what kind of variable, what kind of data of data is this? Is it categorically or otherwise?
Categorical.
Is it a categorical instrument?
It is categorical. Very effective.
We have this now. We have, how many variables do we have here? We have 1, 2, 3, 4. We have 4 here.
4.
Yeah, we cannot see barrier. And I'm thinking that the barrier has been mixed up. Somewhere here. Duration of time you have been involved in school health service, your responsibility. Are you involved with school health service? Are you of this? Blah, blah, blah. The school should be, who is the people? Who are the people? What is the role you have played? Do you have school health challenge? Is health information? Gentlemen and ladies, we can also, is there opportunity to strengthen? Does the school have sick bay? We cannot see barrier here among these questions, spelled out as barrier. It's not. Focused, it's a mixed mode. We cannot see barrier here. So therefore, we cannot. The instrument and the project is not well written. And you can see, I'm sure by now we are getting close to how projects are written and how it should be. We've seen one of the statement category, which is categorical statement, and but we cannot see barrier. So as a matter of fact, we cannot conclude that what we can use for this hypothesis, because the instrument is bad, and the objectives are also badly worded, as well as the hypothesis. I think what we'll do next class, I'm not going to pick previewed again. Previewed are usually a test data that they just push, copy and paste document to us. I think I will pick a post-field data. At least post-field has been presented and has been corrected. I'll just pick a post-field data for us, and we'll see how we can look at this. And I can still pick that before we go anyway. It's just to show us how it works, and so that we don't keep postponing. We see you can still manage to have 5-10 more minutes, in addition to the 1 minute to 9 we have. All right, to ask the question that Mr. Afolabi asked earlier, you can see that we cannot get anywhere with what we were doing, because the title wasn't clear to start with. But for us to have a good project, it tells us that there must be a marriage. When I say marriage, I mean a handshake. A handshake is synchronization. Another word is harmony. There must be harmony between your title, between your objectives, between your hypothesis. When you say objectives, that covers research question and hypothesis. Between your title, your objectives, your theoretical framework, and your design, as well as your instrument. I've mentioned 5 things, okay? And I'm going to list them now. Number 1, your title has to marry what? Objectives. Otherwise, there will be a problem. And that has to do with theory you are using in chapter 2. And your what? Your design, the kind of design you are using. And lastly, your instrument. These 5 concepts has to what? Has to be in agreement. Right now, we saw a question. Hypothesis, we saw this. It's not in agreement with this. We could not find barrier in the instrument. We cannot go forward. So that means there's a problem somewhere. It means the whole thing is just wordly created or badly created. So when you are writing a project, you must dream it. You must put it in good shape, in agreement to what? Statistical analysis. We have the idea now, but we cannot bring out what? The theory we have is not actually giving us the what? The practical we had is not we can't draw that out from the theory we have here. Do we have any question? I wish before we go, I want to pull out one post-field work for us so that if we can still get a good grip of what should be done, with the assumption that anyone I'm picking out, I'll go to public health now, and I think I should remain in nursing for my own comment best known to me. Don't ask me why. I rather remain in nursing rather than going to public health. Is there any question further on what we have just done? I want to pull out a post-field work to see if we can also get a practical, deduce a practical statistical solution to the work. Because when you are writing proposal, they will ask you, how do you want to analyze this? You must give us idea of what you want to use. That is the statistical tool you wish to use. Okay, so any question here, or do we proceed?
Sir, there's a question in my mind, sir, with the assignment you gave to us.
Okay.
I tried to do it myself. The data set you gave to us for the two tests and the independent tests, the data set was much, and I tried to make it independent. What is not, it's not activating. I pressed continuous. Okay, was not active. So I tried.
Don't worry, Mr. Afolabi, I have solution for that. I intentionally gave you that to test.
Okay.
Before now, I have been doing the extraction for you. You will notice that. For the one I sent this morning, I sent only 2. Why? There were more than 2, but I remove what you don't need. And I want you to also do the same, and a number of people got this right. So, sir, what you need to do, go to the question. Look at the variable the question is requesting for. Only the 2 variables should remain. Every other thing remove. I intentionally left it, voluminous, so that I want to test your intellectual ability. And I'm so happy that a number of you got it. I don't know. Do you understand me now, sir?
Yes, sir.
Good. I intentionally gave it to you. It's a test of your ability. I gave you clumsy data so that you will extract what you need and disable what you don't need. And I'm happy that a number of us got it. It's part of the training. So please go back. Look at the question. They will tell you what is needed. Then write it down. Then go to the data, remove what you don't need, deal with what you need, and that will give you the results.
Okay. Thank you, sir.
Do we have any other question, class? Do we have any other question? All right. Just permit me before.
Sir,
Yes,
excuse me, sir.
go ahead.
Can we have like a feedback for the assignment so that we know how we are getting on,
You
sir?
are going to have a feedback for all. I'm going to give you a feedback, but I want us to finish by next week.
Okay, sir.
I want to.
Thank
It's only. If I tell you this is easy for me, I'm lying. It's very very challenging. When I mean challenging, you can't teach a statistics without without reading yourself. So I can't go to a class without reading, even if it's not statistics. I teach research. I teach undergraduate. You read the moment your students are reading. You read ahead. You read ahead so that you can answer all the questions. If you look at coming to class with this SPSS, most of the analysis we are seeing, I have done it before class, and I also have a lot to do. Someone picked some. I mean, was with me this morning as early as 2 a.m. when I was working. I don't know. I don't pick names, so she asked question and I responded. I was happy she was also online. That tells you how early. Thank you. That tells you how early I wake up to prepare my class. And that is how you have to keep up with it. Okay, so what I want to do is that the moment we are done by next week, I will now go back. I'm not reading for another class again. I'm going to take all your assignment, one after the other. I will evaluate and get back to you. Definitely, I'm going to do that. That way informs our results. And at the end of the day, I'm going to tabulate your performance on a table based on assignment 1 or practical 1, practical 2, practical 3, practical 4, and I will send it back to you. So it's something that I have to do. And that's why you have to keep all the notes I'm sending to you, because when the result comes, you have to compare your result with my evaluation. I mean, your solution with my evaluation. Thank you so much. Do we have any other question? All right, I think you should permit me. Let me work on another project that I know that is visible. I have a lot of junks on my system here that are not projects reliable for illustration. Let me work on a good one and prepare for next class so that the moment we finish regression and multiple regression, I just pick another one that I have worked on that I know that I can produce both the title, the objectives right. They are in good agreement with the instrument, and then we present. I hope that goes for everybody. Is that okay for us? Hello, class.
Yes, sir.
Is that okay for us?
Hello, sir. We are with you, sir.
Okay, I am asking if that is okay for you.
Yes, sir.
Okay, and other thing I
Yeah,
can.
sir.
Okay, one other thing I can do. I can pull up a project and send it to you as an assignment. And beside, I'm going to give you another one on ANOVA, and I will give you just this one. Just indicate to me in the front the kind of analysis. I think that's fine. I think that's fine, so that you will think about it. You'll be able to resonate on what we have done and bring solution out rather than having a general solution in class, because once somebody mentioned a particular solution, even though the solution may differ from your thought, you also subscribes to it, and at that point it does not show or gives us the real idea of what you have. I think I will go with that line. I'll give you something which is just a line. Yeah, it's not an analysis. Just tell me the kind of analysis required. Write it in front and you submit back. In addition to the ANOVA question that I'm going to send to us, I think I prefer to work that way. That will tell me if we are really catching up or we are still reading along the line. Okay, this is 8 minutes after 9. May I ask if we have other questions, clarification? Please, this is a class where we all discuss and we are supposed to make contributions. It's not a church where the preacher will just speak and go away. Please, let's make our comments known and contributions. All right, and at the end of the class, I'm going to give us the end of the class, it's not going to be next week. After the class is over, I'm going to draw an instrument and give that instrument to us to evaluate what you have benefited in this class. And you also show your interest if you desire to have an advanced statistics later. But before you can show us that interest, you must understand the basics of what we have done so far. So we have instruments to measure our knowledge. Remember, I intentionally did not measure our knowledge when we started, because most of us, I placed us on a 0 level, and I'm biased by doing that. It's not right, but I just want to know how this lecture has affected your research, how it's going to help you to navigate and to do your work yourself. So keep working, and by the time we finish, I'm going to give us that instrument, and it's going to help us to know if this lecture has actually met the investment you made. We paid 50,000. Does it worth the money, or rather, has it been a wasted, resources and time that we have invested? We also see. All right. With this, I think we've all done very good today, and I wish us a wonderful and a nice day at our various places of assignment. Thank you so much, class.
Thank you, sir. I wish you same, sir.
All right. Have a nice day, everybody. Bye-bye.